Welcome. Good afternoon. We are very happy to have you here again. I think it's the first live event that we do in Hasselt after the first one, which we've done 3 years ago, just in October before Corona started. So we're very happy that we have the chance to see you in person again. We are Ecker and partners. My name is André Michalik. I'm one of the partners of the company. I will perhaps just first, let you know that you will get the slides afterwards. That we would like you to pay full attention to the speakers and to what they have to say about the topic. Afterwards, we share the slides. We're also recording a session for the benefits of our colleagues who are located far away from here, you could say. I will tell you a bit about the company. I cannot spend a lot of time because you won't believe how much you're going to hear from the speakers today. So they will not be very happy if I spend too much time on the company. We were started in 1999 by Anne de Klerk, who is also here. But we have grown, so I think at that time it was a small company of 3 people pretty much. We have grown in the meantime to a company with 22 qualified patent attorneys, 3 trademark attorneys, one of whom is here today as well, 2 legal counsels, and a team, well, a top-notch paralegal team indeed, which is what you need in this profession. And in total, we are approximately 50 people. What we do is essentially help you in the area of IP law and with the focus on trade secrets, patents, trademarks, designs, and domain names. I said that indeed we have also colleagues who are a bit farther away from here. We have 3 offices in Flanders. We started in Sint-Maarten-Slaten. Then later on, already more than 12 years ago, I think, opened an office in Leuven, and indeed, approximately 3 years ago, opened an office in Hasselt. All right, we can also help you with IP contract clauses. In terms of technologies which we cover, with 22 qualified patent attorneys, we can cover quite a lot. So essentially, we're pretty broad in terms of technologies. Today, we talk about software, that's one of them. Engineering, indeed, as well, biotech and pharma, and chemistry. We also help all kinds of clients. And so essentially, it comes from individual inventors, which perhaps is more rare these days, but to SMEs, which are very often busy with innovation and with protecting innovation. The same goes for universities and research institutes, and also we have a number of multinational clients. Most of our clients actually are from Belgium, or let's say Benelux. We do have then a fair share of clients who come from other corners of Europe, and then we have a number of clients who are actually from overseas. So then we talk about US clients, Japanese, Chinese, and so forth. And as a firm, we've been also busy in a very appreciated way over the last 20 years, which found its recognition in a number of awards which we have received and which we actually continue receiving year after year. So with that, I think you know enough about the firm to start with. We are all very happy to tell you more after the seminar is done. And let me now introduce the speakers. So the first part is going to be given by David Lestari and Jacek Jepa. David is a European patent attorney who is based in the Latin office. Jacek is based here in Hasselt. They're going to talk about the software and AI part of or the patent. Let me put it that way. The patent focus part of the presentation, and afterwards, Jos Meuler is going to add something on top of that, which goes more towards the other IP rights. So with that, I think I will give the floor to David.
Thank you very much, Andre. Thanks a lot. So as Andre said, Jacek and I will start with compatibility of software and artificial intelligence, and then Jos will pick up on that and talk about some other IP rights. Now, I don't know if I was the only one this past weekend that had quite a lot of time playing with the new GPT chatbot, but I asked him a couple of questions about software and AI inventions. Some answers were actually quite impressive. Some answers were a bit more crappy, a bit more weird. But in the end, the chatbot did recommend me to talk to a specialized patent attorney. So I think that we are still not completely out of a job just yet, and we still have some knowledge that we can share with you guys. So first of all, I mean, yeah, as you guys everybody knows, I mean, it has been a huge boom in computer technologies, mainly because of the increased processing power and real-time data processing. We now see kind of all kinds of computer implemented inventions popping up in all kinds of fields of technology. And we also see that with our clients. So as Andre said, we service a lot of different clients in different fields. So we service people in biotechnology, in engineering, in chemistry. But basically, all these people are also starting to come to us with their software inventions, with their computer implemented inventions. And we kind of can't really compartmentalize anymore and kind of put people in boxes. We kind of need to be multidisciplinary and look at the inventions from various viewpoints. Now, traditionally, so I mean, mechanics, for example, and pharma, there's a long tradition of filing patent applications and patents. For software, that was less the case, particularly in Europe, because everybody in Europe was like, oh no, you can't patent software in Europe, oh, stay away from it. And also, like in many research communities, there was also kind of an open source sharing kind of mindset going on. However, some of the big players did protect their technologies with software patents, which kind of forced the smaller players to also look at different ways of protecting their intellectual property. Now, the problem that we do have right now is that a lot of patenting law and patenting rules are actually based on case law, based on decisions made before the European Patent Office or made before national courts. The thing is, this field has kind of evolved so quickly that we right now don't have that much case law to our disposition. So that means that we still have a couple of questions, also a couple of uncertainties towards the future where we don't really know what's going to happen there. And it will take probably will take a while before we get that case law also for software applications. Now, what we do see is, okay, mainly, I mean, patent applications are still going up despite the corona crisis, not just in computer technology, but also in other fields like digital communication, medical technology, electrical engineering, and also in these fields, we also see quite a lot of software patents being filed in recent years. Also in Belgium is one of the top 10 filers at the EPO, and we also see a steady increase of patent applications filed in Belgium as well. So, a couple of questions that we get from people is like, okay, why should I bother filing software patents? I'll just keep my algorithm secret. Why do I want to maybe disclose my secrets? That's one issue. Another issue is, of course, even if I get a software patent and I can enforce it, what's the point in spending money on something that I might not be able to enforce anyway? So we'll start with those two questions first, and then we move on to actually looking at your invention. Is it patentable, yes or no? So there are many different ways of protecting your IP for software. So Jacek and I will only focus on the first one, the trade-off between keeping it secret or trying to patent it, and then Joost will talk about the other things. Now, the problem with, not the problem with patenting is, the deal with patenting is that you kind of have to disclose your invention. You have to explain your invention, you have to explain your software, you have to explain your algorithm enough so that somebody else can reproduce it. And that's kind of the deal you make with the government. It's a trade-off we have in the patent system. So in exchange, the government will give you protection, will give you the right. The patent does not give you the right to do something yourself, but it will give you the right to stop other people from doing whatever you claim. So the government will give you that exclusive right. You could actually keep that right if you pay the renewal fees for 20 years. So that's the deal from the government. But in exchange, you share your information, you share your knowledge, you share your know-how. A patent application is published after 18 months so that other people can work on that know-how, can work on that knowledge, and can further improve those technologies. So that's kind of the trade-off in the system. And you can't really try to have your cake and eat it too. If you want a patent, if you want to stop other people from doing it, then you do have to disclose and you do have to explain how theoretically they could do it. Now, the thing is that for some fields, like for example, just maybe some simple mechanical products, you don't have to make that trade-off, because once you put your product on the market, somebody could just reverse engineer it, just open it up, see how it works, and they could copy it anyway. So in those fields, you don't really have to think about, do I keep it a secret or do I patent it? For software, on the other hand, oops, I might have to press the button again. There we go. Software, on the other hand, a lot of the things that happen behind the scenes, a lot of the algorithms that we have, we can keep a secret. We don't really need to share all the details with our clients. So you do have to kind of go through that exercise. Yeah. Now, what's also very important in a patent application is that in a patent, once you get your granted patent, you don't really protect your specific code, you don't protect your specific implementation, you protect your overall concept. And that's why it's actually such a strong form of protection, because it actually also covers all alternatives, or if somebody uses the same overall concept but just writes it in a different program or just makes some minor changes, they would still normally fall under your patent. So it can also be any kind of new algorithm, any kind of small new feature even. It can be based on existing software packages, it can be based on existing stuff, as long as you put in something new and inventive that we'll go into later. And of course, it is independent from the actual programming language that you are currently working in. We try to protect the concept, the algorithm that is actually behind your ideas. It's valid for maximum 20 years. Of course, for software patents, people don't usually pay their renewal fees up to those 20 years. What it does give you is, since it is published anyway, and even if it's not yet granted, it does already give you a head start compared to your competitors. Even if it's not yet granted, the application is published, it will already scare away some people who rather not infringe, who are more cautious in that aspect. And as you know, in this field, just an advantage of a couple of years can already make a huge deal. You don't need those full 20 years, or you don't actually need to go towards the full granting procedure. Of course, on the downside, a patent is expensive. So it costs a lot of money to have it drafted, it costs a lot of money to have it prosecuted. So that is something that you do have to take into account as well. And as I said, you're not sure that you will get it wrong. So the patent goes through substantive examination. And so the European Patent Office, for example, will look at your invention and will decide whether it's an invention, yes or no. A secret, okay, you can think, okay, maybe that's easier to keep everything as a secret. However, if you want to have it clearly shown that it's a trade secret, you have to make some effort in keeping it a secret. And the question there is, how easily can a third party, independently, even if they're not copying you, even if they don't really know what your know-how is, how easily could they come up with the same things and develop it themselves? Because if they do so and you don't have a patent, they are free to do so and you cannot stop them in any way. Or even worse, you've developed something, you think, okay, it's really cool, but okay, I still want to keep it a secret. A third party might disagree, they might develop it themselves independently, but they might patent it themselves independently. And then maybe you, even though maybe you had been the first one, it puts you in a very difficult position. And then lastly, I think that's more specifically regarding startups, what your investors expect with regards to protecting your intellectual property. So our practical advice, and that's also mainly, I mean, for people that only work in software, maybe that doesn't help very much, but for people like tech transfer offices or people involved in various technologies, is to look at their other process or method type of inventions. How do you, if, for example, if you have a chemical process in a chemical plant or lab process, it's also something that cannot be seen by the outside world. It's also something that you might be interested in patenting in. You kind of have to make the same considerations for software inventions. So try to get that balance right, but of course, we are there to assist you in kind of making the right decisions. But then the second question is, okay, maybe I want to file a patent application. I'm ready to share some of my know-how. How much do I need to disclose? And so there, the problem is normally, and this applies to all kinds of inventions, so not just software inventions. Basically, so you have to explain your invention in enough detail so that somebody else could just copy it. So they're not allowed to copy it if you get a granted patent, but they should be able to copy it based on the explanation you give in your patent application. And so the same holds for software inventions. So it has to be repeatable. It has to be able to work. And so we really need to describe it in enough detail. What we do see in practice, and this is, I mean, maybe I shouldn't be saying this, but this is what we see in practice, is that for certain fields like chemistry, this bar is extremely high. So you really have to go in lots of details. If you have a certain parameter, you have to kind of explain very detailed methods on how to obtain this parameter. Examiners don't really push us that far with regards to software inventions. So basically what we see is we do have to share the main algorithms, the main ideas. I mean, you can't just go like, okay, this is the input, and then something happens, and then you get the right output. No, we have to really go into detail in what your algorithm does. But we don't have to share all the minor or all the very small details. So that might play a role for you as well. Just know that, okay, your main concepts will become public after 18 months. But if you have some minor tweaks or some minor improvements that would rather keep as a secret, right now in the current state, we can actually still do that and keep that a secret. Just know that whatever you don't put in your patent application, you cannot use later on as a fallback position. Now, this is for classical software, classical computer implemented inventions, which the EPO sees as predictable, as something quite static. For machine learning, it's a bit more difficult. The thing is, we cannot file any data later on to show that it was enabled. So here for machine learning right now, we just try to describe it in as much detail as we can, but still has to fit in a patent application where you still have a limited amount of pages, so you have to pay page fees. So we do have to kind of make a practical choice there. And what we don't know is that there might be a stricter approach in the future, because right now we do feel that whatever is disclosed in patent applications might not be 100% repeatable. I mean, there might be some details missing on your AI invention, so that this requirement is not met. What we do see is that in the academic world, some journals are getting stricter. The Japanese Patent Office is also getting stricter. Right now, the EPO, nothing is changing, but we wouldn't be surprised if in the future, due to case law or due to other decisions, this bar will be raised a bit higher. So at this point, it's better to share more information than less, just to make sure that later on we don't fall into problems when the bar is a bit higher than it is right now. So once you get your patent, for example, so you say, okay, we've got our patent, we wanted to disclose it. Okay, that means software is worldwide. How do we enforce such a patent?
Indeed, so as David already mentioned, one of the advantages that you have in software is that you can keep your product quite hidden from your consumers and your clients. However, the same advantage turns into a liability when you try to actively enforce it. Because of course the same is true for your competitors. If they are selling a product, you can't just take their product apart and look inside, are they infringing manufacturing which you have protected? So, however, luckily, unfortunately, in current the current courts do allow for procedures for you, or to be more exact, an expert appointed by the court to have a look inside these algorithms to check whether or not they are infringing your patent or parts of your patent. Of course, this information will not be available to you due to secrecy issues, but there are ways to have this description of their product available to you. This is called descriptive seizure in Belgium. It says description. And similar arrangement exists all over the world. However, in this matter is a bit more tricky because, of course, due to the way that software is written, this can be very distributed. You can have your client device, which is in one country, the server, the cloud, which is in a completely different continent, perhaps even, which then get processed and sent back to you. All these components then have to be accessed by your local laws, which can vary in terms of infringement. And you also have to convince the local judges to even allow this, right? So this can be a bit more tricky to actively enforce it, but there are ways to do it. On the other hand, it's also important to like David also mentioned, there is a very important deterrent effect for having a granted patent, especially in a high throughput environment such as software, where just the fact that your competitor knows that you have a granted patent to a certain technology means that they already have to spend resources studying your patent, analyzing it, thinking maybe of workarounds, because of course you don't want to infringe a patent and go to court. And this, takes not just resources, but also time which you might not have in a software environment where you really want to be the first on the market, right? So our general advice is you really to look at it the same way you would with any type of hidden patents, is just to to primarily take advantage of the time you gain by having your patent granted, and then look around whether or not someone is infringing it and see if it's worth the cost to actively go after them. But this, of course, has to be seen on a case-by-case basis, of course. Huh? Now,
sorry if I meant, in practice, do you see a lot of these script procedure lawsuits and stuff like that?
Well, it's less so in Belgium at the moment, but it might increase because this is completely off topic, but there is a European General Court being arranged in Europe, a central court, which will be dealing with all these matters, which also have arrangements for having these descriptive seizures. So this means that these type of court cases can be more common in the future. But it's a little bit too technical to go in detail, but we can discuss it afterwards if you want. Now, to fully protect you, there is some advantage to have some intelligent claim drafting. So just let's start from the basic, because I know not everyone here has experience with patents. So the way your patents, the protection they offer is by you have to describe whatever invention you have in words. We call these words the claim set, basically, which are at the end of your patent. And there are historically two types of claims, right? You have claims directed at tangible features, which are like products, apparatus, computer programs, things you can touch or hold and sell actively. And then you also have process claims. So these are intangible features, like a service that you provide or a method that you perform, right? Now, in terms of enforcement, you ideally want to have product claims, because those are the things that your competitors will be infringing directly. They are the products that they sell to your potential clients. However, with method claims, even though you will oftentimes see that software is claimed in the form of a method, because that's the easiest way to explain it to an examiner, how your algorithm works, they are typically infringed by your customers, because there will be a step of getting data and outputting data, which is not on all the steps will be done by your competitors directly, right? So what I mean by intelligent claim drafting is that at some point before drafting or during drafting, you have to really consider who will be infringing the claims and where they will be, because all these aspects can be performed by different parties. They might be interconnected, but they also might be completely separate in different jurisdictions all over the world. So luckily for us in Europe, it is possible to claim in a single claim set all these different aspects all together. So for instance, an exemplary software patent claim might look something like this. You will have a method, then you will state whatever the purpose of your method is, output determining some parameter, and then you will recite all the steps that you need to perform your algorithm, right? This might be chronological or not, doesn't really matter at this point. And then towards the end of your claim set, you can have an apparatus, or for instance, a computer, which performs this method, or a computer program, which, when run on a computer, will perform this method. And this way, you can protect both the product and the method in a single claim set, and hopefully, protect your invention from different angles and prevent, access to potential competitors. This becomes for software, it's quite easier because it's just an algorithm, but it becomes even more complex when dealing with AI models, because an AI model is not just a trained model, it's also training that data which you need to train that model, and the output which the AI model will generate once it is trained and you input new data, for instance, from your client into it, right? And ideally, you would like to protect all these parts separately, because of course each one of them will be infringed by a different party. However, oftentimes your invention just lies in one of these one of the parts of this AI model. So then you also have to consider what is more valuable, because of course your invention might lie in a data set for training the model or the architecture, but it's very hard to see whether or not a competitor is infringing your claimed data set, right? It's much easier to see what type of product they are selling. So somehow linking them together in the claim can make it more easy for you to monitor potential competitors and actually start a court case proceeding or convince a judge to allow access due to this descriptive seizure. So by intelligent claim drafting, you ideally protect all concepts available to you. Now, in terms of liability, there are some the issue with AI is that a lot of people, especially those who are not knowledgeable about the interior workings of their system, they just download some model from the internet, they feed it with data, but they don't really know what's going on inside that box, or they don't even consider it. They're just interested in the outcome of whatever this AI model generates. In that case, it becomes a little bit more tricky, because who has the burden, who is liable for infringement? Because of course you cannot, proceed against the AI model. It has no concept of infringement. You can't really drag it to court either. Or so then, who becomes liable? Is it the user of this AI model? Is it the developer? At the moment, we don't have sufficient case law to fully answer that question, but it will be very interesting to see how this proceeds towards the future. But for now, there are some questions remaining still, but we will get to it towards the end of the presentation. So once you're convinced that you should get a patent, now we will quickly see what are the requirements for patentability.
Yeah. So imagine you've decided, okay, I don't want to keep it secret. I'm ready to file a patent application. I'm also kind of understand what the limitations are with regards to enforcement, but actually it's like, okay, there are maybe ways to protect my invention anyway. Of course, you also have to convince the European Patent Office that they should give you a granted patent, because they just don't give it to you for nothing. There are three main hurdles that we are talking about today. And so basically you have to survive each of them. So the first one is the software exclusion, and that's actually where the European Patent Convention says that software and computer programs as such are not considered an invention. So that is also why historically people have been screaming, "Oh, you can't patent software, forget about it." So we'll talk about that one first. Once you've survived that one, you have to be novel, and once you are novel, you have to be inventive. I will discuss each of these different steps in sequence. So the software exclusion. So it's a bit different in Europe and US, but in the end, it kind of boils down to very similar concepts. Basically, in Europe, you can get a granted patent in all fields of technology, but there are some exclusions. And so some things are not considered inventions, and that's basically all the things shown here on this graph. It includes scientific theories, discoveries, mental acts, game rules, aesthetic creations, business methods. But for us, which are the most important ones, it says computer programs, presentation of information, which is also used very often in software inventions, and mathematical methods. However, what's very important is that the European patent law only excludes these things as such. And what does that mean? So basically, patent protection is specifically reserved for inventions in technical fields. So you have to have technical teaching, you have to solve a technical problem. What is excluded are all things that are abstract in nature. So anything that you could do in your head, for example. And actually, historically, computer programs have just been seen as something that you could do in your head. If you're smart enough, you could just go through all those steps in your head. Of course, nowadays, it's hard to find people that are just as smart as certain computers. But in theory, I mean, many of these algorithmic steps are things that you could do in your head as long as you're just smart enough. And so that is excluded from patent protection because you don't want to block people from thinking. I mean, we're not there just yet. But they add that as such term in there to prevent a too broad interpretation. And that means that if you put one thing, one word, just one simple word in your entire claim that is technical, you fall outside the exclusion. So basically how it works is basically if you try to claim a computer program comprising a step, just a random computer step, that will be considered non-technical and excluded. However, if you add that you actually use a computer to run a computer program, I mean, a computer is something technical. I mean, you can't have a computer in your head. You have to have a computer. Then it's technical. And just adding this one word is enough to escape the software exclusion. And basically, this is what we call a mixed type invention because we've got a couple of steps that are non-technical, the first two steps, but you've got that computer in there, which is technical. So that's more than enough. There are multiple different ways of getting outside the software exclusion. So as Jacek said, we will be looking at different types of claim categories, but there's always something technical in there. It's like a computer implemented method. So it's a method, but it's running on a computer. So it's technical. A computing system, a storage medium, all these features are considered technical by the European Patent Office. So we've got some exercises for you guys here. So you will have to participate. So we've got a couple of fictitious claims in here. And so this first claim is more from the medical field. So we have a method for determining oxygen saturation. We get signals from pulse oximeter. We normalize, we do some mathematical things with those signals, we do some stuff with it, and in the end, we derive the oxygen saturation based on those signals. So according to you guys, is this method technical? Are there technical features in this claim, or would this be excluded? Excluded. Yeah. So basically, you could do all these steps in your head, receiving signals, doing the calculations in your head, outputting, deriving that value of oxygen saturation. If you're smart enough, you could perform these steps in your head. So this kind of claim would be excluded, would fall outside the software exclusion. If I just add computer implemented in there, will it still be excluded? No, it's got a computer in there, we've got that one technical feature, and that's enough. So just remember that software exclusion that everybody talks about, it's as simple as that, you can just solve it this way. If I maybe add in, I take out the computer implemented, I add in the first step, measuring with a pulse oximeter. Is it technical now? Yeah, because you need that pulse oximeter. So again, this is an alternative way of getting outside that exclusion. Of course, in this claim, you do need the actual step of measuring with the pulse oximeter. I mean, if you are running the calculations in a different place outside, you will not fall under this claim. So the computer implemented claim is still the one that gives you the more broader scope of protection than the second one. Now, an example from the chemistry field. So you've got your polymerization plant. You want to calculate the VOC content. So basically, you put some inputs through an interface component. It does some calculations based on mass transfer theory, and you get some output through an interface component. Would this be technical, yes or no? And why would it be technical? I see the wood moving, yes. Let's go back a bit. Presentation of information. So the interface component is not considered technical. So here, we think it might sound technical, but no, it's not technical. If we add the computer implemented, we've got a computer, that's enough, it's technical.
If you add the screen for presenting.
Yes, if you add the screen, like you would have to literally add providing input to an interface component projected on a screen, and that will be fine again, but we need the screen. It seems silly, but there is a reasoning behind it. Basically, the legislator wants to block you from protecting things that you could perform in an abstract way without using anything technical. So that's why that article is in there.
It's not that every step needs to be technical.
No, just one technical feature somewhere in your claim. Doesn't matter where, somewhere in your claim is enough to get out of the exclusion. Here we have three claims. We've got a transmitter device, a receiver device, and then a system comprising both of them. And actually, the invention is in the steps A and B and C and D. Are these claims technical?
Device.
Yeah, so you've got your devices. So here you don't have to change anything. However, what you do see is you need to draft this properly because it kind of depends where your invention is. Right? Does your invention lie in steps A and B? Does your invention lie in steps C and D? So here you could run in possibly other problems, in that maybe not all claims cover your invention properly.
Sorry, just to ask true. If you wouldn't have receiver device, it would mean that the second clause could be invalid in the process, or no?
I'm sorry?
If, for example, you wouldn't have receiver device in the second clause,
Yeah.
then this one could be invalidated as part of all the claims, or the fact that the first one.
No, so these claims just have a different scope of protection.
Okay.
So the transmitted device, somebody who has a transmitted device with steps A and B would fall under the first claim. Somebody else who owns a receiver device would fall under the second claim. And somebody who owns both of them would fall under the third claim. And this is sometimes why we have to draft these types of claims, because you have distributed environments and you do want to be able to just attack one person as one sole infringer, than having multiple people infringing together, because that makes the situation much more complex. So as you can see, actually this hurdle is, I mean, the exercise that showed it, it's really easy to overcome. So if somebody says you can't patent software based on that software exclusion, then they don't really know what they are talking about. So we say, yay, you have survived the software exclusion, but however, you still have to go through novelty and event set as well.
So as easy as the software, getting over the software exclusion seems, the next steps, novelty and event step, can be a little bit more tricky if you're not prepared. From both of them, novelty is the one that's easier to understand. Basically, there's just one question to ask yourself when you want to patent something: does it already exist in the public domain? This might seem like an easy or silly question, but it's very important, because what people oftentimes forget is that your own disclosures also count as prior art against yourself. And we see this especially in university or academia. People want to publish. We all know the term publish or perish. So you want to publish as soon as possible. You want to send your commercial flyers to your potential clients. You want to reach your clients as soon as possible. So of course, you're very motivated to publish as soon as possible. Whereas if you want to, if you want to draft a proper patent application, this takes some time, this takes some resources, especially from the time that you actually realize you have an invention, you have a discussion about what is your patentable matter, what your invention is about. By the time it's written, typically a couple of months can pass, right? Before you even get the resources to have it filed. And so during that time, it's very important to still keep everything a secret. Now, exception to this rule is, of course, if you're working with secrecy obligations like NDAs, because of course, typically you're working together with partners. And that's why I was stressing the word in the public domain so much. So everything shared, any information shared under secrecy obligations, this can be within your own company or with contractors, for instance, it does not count as a public disclosure. On the other hand, always be careful, because once you leave the meeting room with people, even under NDA, you never know what happens with the information you share, right? Once they disclose it, it's also part of the public domain. So it's not a fail-safe system, basically. The second important thing for novelty is that there is no assessment of technicality. So we saw these examples presented by David, and you could see that there are several non-technical steps, which might be related to outputting a parameter, which is like fermentation information, or some mathematical method of calculating something. This is enough to make your invention already novel over the prior art. Now, I will get to, so prior art is everything that has been published before the date of filing of your application. Now, inventive step, it's a little bit more difficult to fully understand, and it also varies geographically. So I will not spend too much time today on, going over all the basic details over inventive step assessment. But what's important to understand is that for novelty, typically your invention or your claims will be compared to a single document. However, for inventive step, the examiners are allowed to combine multiple documents to try to see whether or not what your invention is, whether it is really inventive. So basically, is it straightforward for a person, one of your peers, to develop this invention? Is it too obvious or not? And it has to pass this hurdle. Now, this sounds very subjective because, of course, there's some form of interpretation done by the examiner. How do they combine documents? How do they combine information into separate documents? And we see that this interpretation really varies in different jurisdictions. The US has a different way of looking at it. They are, at least to our experience, they like combining documents in very weird ways. But in Europe, we do have a more objective way. We call this the problem solution approach, which is basically an algorithm that the examiner has to follow, which determines whether or not these documents can and may be combined to generate your invention. And it's important for you to realize that usually inventive step is a major part, if not the most major part, of our negotiations with the examiner to get your patent granted. Now, to give you some feeling about how a typical patent procedure, examination procedure goes, we'll have a generic example. So let's say you come to us, you tell us, look, this is our invention. We want to do something with our software system. We will prepare a claim set for you, which has all the steps of your algorithm. So you might receive some data, process that data, calculate some parameter, and then output it. And your scope of protection then is determined by all of these steps, because of course someone who is missing one of these steps in their infringing product, or well, they won't be infringing. They will because one of the steps will be missing. So the scope of protection is determined by this pie chart, and all of these steps have to be present if you want the person to infringe your invention. So then you submit this as a patent application to the EPO. They will do a prior art search. They will typically find a couple of documents which they consider relevant. So the first document we will refer to as D1. They will cite against you. They will make a side-by-side comparison. And they will find, for instance, for example, that all of the steps that you have recited in your claim, A, B, C, and D, are all disclosed in D1. In that case, the examiner will simply say, sorry, your claim lacks novelty, because it is already publicly disclosed fully. So, of course, we at that step, we don't give up, because now that we know that D1 exists, we can change the claims in a way to become novel over D1. So, for example, we say, okay, the generic step of outputting any parameter is known, but we want to really output a very specific type of parameter, which is important for our invention. And we change step D by step D1, and we resubmit this claim set, and we tell Mr. Examiner, look, our claim is novel. He will do the same comparison, and he will agree with you, yes, your claim is indeed novel, great. Now we pass on to the next step, which is the inventive step. And for that, in that scenario, he will just tell you, look, I actually found a different document, which I refer to as D2. And it's true that in D2, some of your earlier steps, A, B, or C, whichever one doesn't really matter, it lacks one of these steps, so it's not novelty destroying. However, it does disclose this step of outputting this very specific parameter, right? So he will try to combine these documents and determine whether or not it's inventive. So like I explained earlier, in Europe, we will use the problem solution approach, where basically we'll look at the technical effect caused by this difference of D1 to determine whether or not this solution that you provide, having this step D1 in your invention, is in fact inventive. Now, of course, this is not, it's easy to explain with a generic example, but in reality, you really have to look at it case-by-case basis, because every invention is unique, right? Every parameter, every prior art document is also unique. So let's say for the sake of argument, the examiner still is not convinced, and he will tell you, look, I can easily combine documents D1 and D2 together. Your claim is not inventive. At that point, we still don't give up, because we really want to have that patent granted, right? So we further amend our claim, and we add another parameter, a second parameter, and we go like, okay, so neither D1 or D2 disclose this step of adding this second parameter. And the examiner will look at that, and you say, okay, you're right. No prior art documents actually suggest that this parameter should be disclosed. So it looks like your invention is inventive. However, this is true for traditional, let's say, inventions, for instance, chemistry or biotech. However, in software, we actually have an additional step, which it's also true for other fields of technology, but this extra step of technical assessment is commonly applied in software evaluation. That is that, referring back to David's slides, some forms of subject matter, like presentation of information, computer programs, mathematical methods, they're considered non-technical. So, and the presence of an inventive step, by definition, can only be supported by a feature which provides a technical effect, having a technical purpose. Which means that if these steps, D1, D2, are non-technical, the examiner just simply remove them from the claim set. So in our first example, let's say only D1 is non-technical, because essentially outputting a parameter is just presentation of information, right? You will just delete it from the claim set, but luckily you still have step D2, so you can still be inventive. However, what we oftentimes see is that a lot of features in software are fully non-technical. So in this case, also step D2 would be considered non-technical by the examiner, and he will not even consider it for the assessment of inventive step. And he will just say he doesn't even need to D2, he will just state it's not inventive over D1 altogether. And then what? You're stuck, right?
Yeah, sorry guys, I'm back with these examples again. Not finished with these just yet. So basically what we need to do for inventive step is, before the examiner actually looks at those documents, you'll just look at which steps are technical, which steps are non-technical. We'll just, like Jacek said, we'll just ignore all non-technical steps, and you might be left over with very little information to base your claim on. So for these examples again, if you remember, so the first claim, software exclusion, do we need to worry about it? No, because we have the computer in there, we have the oximeter in there, we've got technical features in there, so that software exclusion does not play a role here. But when we are evaluating inventive step, which steps of those 3 steps would the examiner consider non-technical, and would he not take into account for inventive step? Let me ask you differently. Is the first step technical? Yes, because they have that measurement with the oximeter. The second step, normalizing electromagnetic signals. Is that technical? No, that's a mathematical method. And determining oxygen saturation based on those signals. Is that technical? No. So basically, those 2 steps would not be taken into account for inventive step. I already hear you like, yeah, but perhaps my invention is the steps A, B, and C. This does not really help me very much, but we'll get there. The second claim, which steps are non-technical?
First.
The first one is not technical. The second one?
Second one.
It's not technical. The third one?
Third
Voila. So none of your steps are technical. So basically, you just left with a computer implemented method. So basically what the examiner might say in the situation is, a computer exists. The fact that you use it to do some calculations, and I don't care about the calculations, step, means that you are not invented over an existing computer. And so this sometimes happens, but there is a way out. So at this stage, you're like, okay, so you talked about it's so easy to overcome the software exclusion, you don't need to worry about it, but now we just stuck at inventive step. That doesn't really help us. Luckily, there's a very important way out of it, and that is we'll make a difference between mathematical methods and presentation of information, because those are the 2 most important ones for your software inventions, is that we can actually promote our mathematical steps to technicality. How does this work? So basically what the European Patent Office considers mathematical methods, so this is an umbrella term. I mean, it doesn't have to actually involve detailed mathematics, but it's basically, they call mathematical methods, I refer to mathematical methods, anything that's related to algorithms, simulations, modeling, and also everything related to AI and machine learning is considered mathematical methods for the field. So each time I say mathematical methods, if you are working in AI, that's what we're talking about. So, as you know, a mathematical method, it's in the law, is non-technical per se, just like the other features that we had in our hive diagram. However, for the assessment of inventive step, every feature that assists in a technical effect and that assists in solving the technical problem should be taken into account after all. So basically, if you have a mathematical method, but that mathematical method or that mathematical step helps in solving a technical problem, it should be promoted into technicality, and you should not delete it from your claim, and you should take it into account by the step after all, which makes it much more difficult for the examiner to find second document matched with the first document, and which increases your chance of getting a granted patent. Now, there are some limitations, is that if you want that mathematical method to be promoted into technicality, you have to show that you solve a technical problem. It helps in the technical effect, but it also has to be in a specific field of technology. And what we mean by that is that you cannot try to claim, for example, you've got a new machine learning algorithm, and you see like, okay, yes, well, you could use it in chemical engineering, but you could also use it in mechanical engineering or in telecom devices. I mean, this is brilliant stuff. You could use it anywhere. That we can't claim. We have to limit our claim to one very specific application of technology. That's kind of the trade-off that we have there. So just a method for controlling any technical system would not work, but a method for controlling an X-ray system, which is limited to the X-ray system, and where you have your algorithm that has specific advantages with regards to your X-ray system, that would work to promote it to technicality. Now, there are lots of different examples in the case law. It's just kind of to give you a feeling of what could be patentable, because in the end, these are the software inventions that will be patentable or could not be patentable. So controlling specific technical systems or processes should be enough to have your mathematical steps to be promoted into technicality. Enhancement of images, videos, particularly in the medical field, but also in broadcasting, is also considered technical. Denoising is considered technical. Working with speech signals is considered technical. Encoding, decoding can also be considered technical. Anything related with sensors, so if you have something with sensors going on in your technology and your software uses those, if you can kind of show that your algorithms show an improvement with regard to the use of those sensors, again, that will be technical again. And analysis of DNA for the people working in biotech, that can also be seen as technical. Examples of stuff that people come to us when we sadly have to tell them, okay, your algorithm is really cool, it looks really nice, it might be novel, it might be a huge commercial success, but we simply cannot patent it because it's not technical. Are things related to business methods, stuff that we've had, dating apps, for example. It's not dating, it's not considered a technical field. HR tools, having a nice user-friendly layout, user-friendliness is not considered technical, sadly enough, so you might have a huge improvement with regards to user-friendliness. Sadly, you will not be able to patent that kind of software invention. Anything related to investments, business stuff, marketing and advertising. Again, you might have really cool software with really cool marketing tools and you might make millions out of it. That will not be patentable, sadly enough. So our practical advice is, okay, if you want to patent your software, we might be able to do it if it is applied in a specific technical field, but we will also have to limit your claim to that application in a technical field. You cannot be greedy, you cannot want to protect also the use of your software in completely different fields. It should be specific and not generic. Also during the drafting stage, we will ask you lots of questions. I mean, how does this specific step, why does this specific choice of training data or this specific algorithmic step improve the system, improve the technical effect that you are trying to explain? And we will always explicitly try to link each of these different steps to the final technical outcome, because later on during the discussions with the examiner, we want to show the examiner, like, no, you should not scratch out this step, you want to do this step, because it does actually play a role in the technical effect and play an important role in solving the technical problem.
If you have different specific technical purposes, you have to apply for multiple patents.
Yes, exactly. It really depends on how different they are. If they're completely different, then you might want to think of maybe filing 2 patent applications on the same day, so that they don't create any kind of hierarchy towards each other. If they are very closely related, we will try to draft the claim a bit broader. I mean, specific and generic, there's no hard cut line, there's always a gray zone, so we will always try to push within that gray zone, so we can try to be I mean, our first claim is always a bit too greedy with our first claim because the broadest, the most powerful patent that's possible. So we will try to be a bit more greedy, but we will put in enough fallback positions in the description, limited to more specific applications, just in case that our initial attempt was a bit too broad, too generic. But we will try. I mean, we'll always try to push the limits with the examiners there. But if it's completely different technical fields, you might want to consider just trying two different patent applications.
So yeah, another example of non-technical subject matter which can be promoted based on the technical contribution that it makes towards solving a technical problem is presentation of information. In our personal experience, such contributions are frequently found in specific domains such as healthcare, because we can all imagine, for instance, a surgeon doing a surgery, having a camera, receiving some input from that camera. What if you generate some nice overlay which shows specific parameters or specific lines which show where he has to perform a surgical procedure? This can, of course, improve the quality of his work that he provides. And the same is true for other healthcare professionals, right? The way they are presented with information can improve the way they perform their work. Now, the requirements for promoting a feature related to presentation information is very similar to the steps we performed for mathematical methods, so I won't be going over them again, but there are some very important questions which you have to ask yourself. Does the presentation of this information feature really credibly assist the user in performing his technical task? So you really must be performing a technical task, and there has to be a continued interaction between him and the machine outputting the interface, right? So it can't just be an alarm that goes off, because this is not a continued or guided interaction, right? And for when trying to claim such a path or subject matter or invention, there are two important questions you should ask yourself. Firstly, what is the information which is presented to the person, right? Which parameters are they shown? And then how is this information presented? And with how, I don't just mean the display, but also how are these parameters calculated and how are they then put or output to this person? Because from our experience, the issues typically arise because our client wants to patent what they're showing. So for instance, the pulse or the oxygen level of a patient, and they want to keep it a secret on how they determine it or how they calculate how these parameters are determined. And it's really important for your application. Maybe, at first step, you can try having some broader claims, but at least in the description, you should include all of these steps. And typically, the invention really lies in the combination of what and how this information is presented. So, returning to the example.
Sorry about that. We're back again. So, remember last time with the examples, we kind of, okay, we had to get rid of pretty much all of our claims, so we left with nothing. But now we know we can promote mathematical steps into technicality, and we can promote presentation of information as technicality. So we're looking at our claim again. So first claim, you still remember which steps are non-technical. Yeah, so the second and the third one are non-technical. Oh, sorry, I went pretty fast. The second claim, which steps are non-technical? All three of them. Sorry, spoiler alert. And the second step we now have, okay, so normally the examiner, that's the first thing the examiner will do is just get rid of those steps. However, if he stops there, you have to tell him, no, I'm sorry, you have to go through the second round as well. You have to kind of check whether any of these mathematical steps or presentation of information steps could be promoted into technicality because they assist in helping achieve the technical effect or assist in helping to solve the technical problem. The first thing you have to know to look at is there a specific technical purpose? Is there a specific technical purpose for that first claim? Yeah, there is a specific technical purpose to determining oxygen saturation in blood. I think that's already quite specific. Is there a specific technical purpose in the second claim? Yeah, calculating VOC content in the fermentation plant, and clearly technical. So we have this specific technical purpose in there. Next step, can we link those non-technical mathematical features to that specific technical purpose in that first claim? Can we link those two red steps to the final result of determining the oxygen saturation? Yeah, I mean, it's clearly in there. You do some calculations, and based on those calculations, you get the oxygen saturation. In the second claim, can we link those steps to getting the VOC content in the polymerization plants? Yeah, you put in some input. Yeah, you do a calculation. So yeah, those mathematical steps clearly are linked to the final technical effect. So here we could argue, no, you're examining, you have to take these into account, particularly because our invention will be in steps A, B, and C, or will be somewhere in the iterative calculation. And that's usually where the software invention lies. So we can take into account for inventive step. Maybe for that second example, so we have these two presentations of information, so providing inputs to an interface component and providing outputs to an interface component. Do you think we could promote that one into technicality? So we have the continued human-machine interaction, the guiding the user somehow, you think?
Yes.
How?
Well, the interface helps in a continuous fashion the process. Like
you could try to argue that, but I'm going to be honest here. Here, probably this kind of presentation of information we will not be able to promote into technicality, just because it does not. The technical problem you're solving is trying to calculate the VOC content. The fact that you're inputting or outputting information to an interface does not really help in solving that technical problem. Not the same way that the mathematical method helps.
It's the fact that it's online, because that's what your colleague just presented, that it was continuous, or that it could guide somebody in real time.
Yes.
Is that not something that's an added feature, like in this first?
It could be, but then it should be more explicit in the claim.
Okay.
So if you have that, then you put it in the dependent claim at least, or put it in the description more explicitly, and then the examiner will add you to add that in the claim. Right now, it's a bit worded too vaguely and too generically. It also covers the situations where you don't have that continued guided interaction. So here the examiner would just not let you get away with it. But if you had it in the description, you could put it in the claims and get out of it that way.
For example, if you would add continuously, would that be enough? Like,
you would still need to argue. You would still, I mean, this is a situation where you would have to be very persuasive and use good arguments to convince the examiner. But I mean, that's always a point.
So if a mathematical method, let's say an AI architecture or network architecture itself cannot be claimed unless you link it to a technical invention. Does that mean that if you would use an existing neural network architecture that has been described somewhere and you claim it in an invention for a different or a new technical purpose, you can do that?
Yes. You will just have to convince the examiner, first of all, that you know, if it's a completely new application and it's existing neural network, you're just using a completely different application, it would be novel.
Yeah.
The thing is, the examiner would try to argue that you're not inventive. He would say like, okay, your neural network model, everything exists, your application already exists. The fact that you just combine the two would not be inventive. But there we would have to, again, there's a lot of gray area in there. So there we would have to argue why it's surprising or why it has certain advantages. Particularly, I mean, if your neural network model has specific advantages towards your new application, that those advantages weren't known before because it was used in completely different applications, then we can say that these advantages were surprising, these were not predictable, and then you can argue that you're inventive. But it will really depend on what the prior art already states. But if you have those advantages in that new application and you argue those advantages properly, you will be able to patent it.
You then still need to include all the technicality requirements, or can you rely on the technicality that was proven by the prior art?
So, first of all, you will have to have the computer in there somewhere for that software exclusion. The rest of the technicality requirements, so your steps can be non-technical, that's fine, as long as you are able to show and argue that your non-technical steps solve the technical problem. So are useful in that new technical application and kind of have an advantage, a surprising advantage in that new technical application. And they promote into technicality automatically. So basically, as you can see, so as long as you can make that argument, you can take those steps into account. And so in the end, if you look at the three requirements, So the software exclusion, that seemed the harshest one, but that's actually the easiest one to overcome. Novelty, it doesn't matter what part of your claim is novel, if it's technical or non-technical, you don't care. If there's just one difference in the prior art, it's not novel. For inventive step, it's a bit more complicated. So we do have to argue that the non-technical steps, and that's usually where your invention lies in this field, kind of assists in achieving a technical effect. And for that, we do have to limit ourselves to a specific technical application. We cannot be too greedy there. Now, when we look at AI inventions, just remember what I said. AI is just mathematical methods. It's as simple as that. Same rules apply, same reasoning applies. And basically, what we see is AI used in a practical setting often leads to a technical advantage. I mean, there's often specific advantages linked to the neural network model that you use or choices, the choices that you have made. You made those choices just because it has some certain specific advantages. Of course, it has to be applied in a technical field. So if you use it for Deep Blue or AlphaGo, or if you use it like in game setting, game rules, remember it's also one of those non-technical things. And also business methods. Again, if you use your AI in a business setting, that won't work. And in order to be promoted, we have to have a specific purpose. So again, for example, use of a neural network in a heart monitoring apparatus. So here, is this claim, which steps of this claim, let me put it that way, which steps of this claim are technical or not technical maybe?
Second and fourth step are technical.
Well, right now they're not technical. As such, the processing step as such is not technical. Yeah, basically, actually, none of them are very technical. So you risk actually losing the entire thing. However, do we have a specific technical purpose here? Yeah, I mean, we're looking at heart monitoring. That's a specific technical purpose. And do our non-technical steps actually do they result in achieving a technical effect? Do they result in solving a technical problem? Yeah. So here, you do have that technical purpose, and you would be able to use all these steps to argue that you have an invention that you are inventive over prior art, depending, of course, what the prior art discloses.
Yeah. So actually, the fact that you claim to be using a neural network, which is something your brain cannot do, is not enough to consider that it's computer-based.
No. So neural network, remember, neural network is mathematical method. Mathematical method is non-technical.
Yeah, so
the EPO assumes that your brain has
question of
crazy capacities. I mean, your brain is some kind of neural network. But so just look at it that way. Neural network, mathematical method is non-technical. However, if you use it in a technical setting to solve a technical problem, it becomes technical. You can't take it into account.
As simple as that. So historically, so AI models have historically always been used for crunching, for instance, large data sets or solving very complex problems. However, we see some movements in the later years wherein AI models are being more and more used towards actually solving technical problems. People are asking AI models, please, I have this issue, how can I solve this? You even have this online models which you can just ask a question, right? So at some point, there's a huge community, and this might be a little bit philosophical. They are asking, should AI then also be acknowledged as an inventor if it helps in providing a technical solution to a problem which is being solved, right? So to answer this question, maybe it's good to take a step back and first consider what an inventor is or who an inventor is. Why do we even have this concept of inventorship and patents, right? Because we want to give something back to the person thinking of a solution towards a technical problem. So they first have the moral right to be acknowledged, similar to a publication or a scientific article. It's important that your name is known, that you made a scientific contribution to society. And secondly, you have the substantive right to invention as an inventor. You should be able to, perform the act that you invented, use the system that you invented. And when we look then at AI models or computers in general, the moral right, as far as I know, to any computer is quite meaningless. I don't think any computer thinks about, their contribution to society or that their name is out there. Do they even have a name? So this part is already meaningless for them. And secondly, at least in current jurisdictions, they're not allowed to hold any property or even be considered an employee and have rights. So also the substantive right is meaningless. And as a result of that, at present, there's no known jurisdiction where AI systems can be considered an inventor. And it's even a bit more complex because even if you include an AI system in your inventors, your application might be dismissed. So our advice is, stick to human inventors only and keep it a secret to yourself. However you got to the information, solve your problem. But on that track, especially with software, it's important to software applications. It's important to understand that typically it's a whole team providing a system or a software implementation. And it's important to keep track of everyone involved in the process to correctly identify all of the inventors. And in this regard, yeah.
You earlier, one of you mentioned that the person skilled in the art should not automatically do it, but the AI system is then also not regarded as a skilled person because if they have to check.
Well, the current AI system will rely on basically using all of the information known to the public domain to solve an issue, while humans will try to find a creative solution towards solving a problem. And there, I think, lies the main difference. Of course, if something is known to an AI model, it should also be known to a skilled person. Because, the way a skilled person is seen really varies from jurisdiction to jurisdiction. In Europe, a skilled person is defined as the person, it can be a whole team of people with different...
But no systems. So those people cannot use AI systems for getting to that solution.
Right now, it's not really done. Right now, they see the person as skilled in the art as someone who can Google really well.
Yeah.
And really good at finding stuff on Google. Right now, it's not looked at someone who can prompt really well. But that might change in the future. That we don't know. So it might be that the person skilled in the arts is defined slightly differently in the future than it is right now.
Yeah. And in fact, at current, we do know that at EPO they even use AI models to find prior art documents to cite against you, right? And to classify your patent. They're much faster at reading your whole disclosure and finding prior art documents, which a person would have to scroll. A computer can search the entirety of the internet in a few seconds, right? However, they're not allowed to use these models to then generate an invention and then say, look, a machine could have also done it. That's beside the point. I think if we do that, we will just kill, not just the patent system, the inventorship system, right? Well, that's a topic, a more philosophical topic, let's say. But at the moment, we should first focus on the humans inventing your inventions. And like I was saying before, it's important to understand that authorship is not the same as inventorship. So typically when you have an invention, you have a person or a group of people who think of a solution or a system, and then they guide a group of people to execute whatever solution they have thought of. So it might be a team, you can have a subcontractor working in another country which does some coding for the user interface, another group which does some coding for so the front end, the back end. There are different parts of a software system, especially when you have an AI system, you have the model, the generation of the data to train that model. These can be done by different groups, but that does not mean that they are all inventors for that invention. But it's especially true when you're from, for instance, a tech transfer office. You have to be aware that there are multiple groups working on this invention, and they all have the right to be named if they made an inventive contribution. Sorry.
No, just a question. Because in practice, you've got a human who is developing something and is using AI, and of course, you're in many of the cases you're not developing the whole AI system yourself, but you use big AI platforms that are out there in the cloud. You even have those models where it's the model themselves that starts learning, where you're not supervising. So it means that the core of your solution is in fact done by a machine, and you're not even knowing what is happening within that black box. So where does this lead you in terms of patenting, knowing that the core of your solution is somewhere in the black box?
Well, that also depends where the invention really lies, because of course the model which you're using is part of the prior art. It's part of the public domain. So just like David explained earlier, you can't just take an existing system, throw in some data, and have it solve a problem for you. That will not be considered inventive. But then you will have to do some tweaking itself. So the invention might be the fact that you thought of using this model to solve a specific problem. That can already be a solution no one else has thought of using an AI model. Typically, in our experience, is that these models still have to be trained and tweaked somehow by a human, because sometimes the output they generate is pure nonsense, and sometimes a part of the solution is also in the output, because of course you have to filter whatever they generate and see how you can practically implement that in your solution, right? So I can't give you a straight one answer fits every question, but those are all the concepts you should consider. Where does my invention really lie? And if the AI model will help, that's great, but you can still, take credit for its work. And so, as I was saying earlier already, you really have to keep track of who contributed, and these parties, they should all be named duly, like basically with a scientific article. But that does not mean that everyone in the chain has to be named on the application as an inventor. You can do it as a sort of benefit, but legally speaking, they should not be on there. So do keep track of the complete chain of transfer, and most importantly, when you are working with subcontractors, also best beforehand agree who holds the rights to the patent, because that's where typically a lot of issues arise. That you might have, for instance, a great idea to implement a solution. You start sitting together on a table, ideas flow, which is very normal. And 1 month later, you tell them, look, I want to file a patent application because I think this is an invention. And they tell you, look, we are the inventors. We should file the application together as joint applicants. And you say, no, the original idea came from me. And then you're stuck a little bit, because they might have done some contribution. So it's best to agree beforehand, contractually, who the rights to the invention will belong to. Will it be a shared invention, or will it come from you?
So before we hand off the presentation to yours to talk about some other types of IP protection, I'm just going to summarize the take-home messages. So first of all, you do need to decide whether filing a patent application for it does cost quite a lot of money, whether that's the right strategy for you. So you do kind of make that balance between costs, disclosure, knowing that you will have to give away some of your secret. You cannot keep everything secret. You will have to give away some of that. But on the other hand, also know that keeping everything secret also comes with risks. If somebody else independently develops it, they are free to do so. Just know that if you decide to file a patent application, do not let anyone tell you you cannot patent software, because everything that software exclusion is ridiculously easy to overcome. That's not the problem. The problem is that it has to be applied in a specific technical field. So if you are working in a business method type of field, then sadly, most likely, unless we are very creative in kind of inventing technical problems there, it will be very difficult to get your patent application and your software invention granted. However, if you are working in a specific technical field, and it can be anything, it can be mechanical engineering, chemistry, pharma, biotech, whatever, you're using your software application in that kind of field, no need to worry. We'll just make sure that we draft it properly and argue that your non-technical steps, your algorithm steps, your mathematical steps, your presentation of information steps, that they should be taken into account properly for the evaluation of inventive step. Kind of also, maybe sometimes we ask you to think like, who will be using your end product? I mean, if it's an engineer or a scientist, then most likely you will be able to patent it. If it's someone with an advertising marketing background or an MBA, yeah, then that should be a red flag. This might not be technical enough. This type of software might not be tangible as such. Of course, particularly for those of you that develop software for different types of technical fields, you also do kind of need to take it into account. If I limit myself to one specific technical field, is it still worthwhile disclosing all my secrets, spending all this money, knowing that somebody using the same methods in a different technical field is not fall under my patent anymore? So that's the end of the patent presentation. So I will call yours to the front.
Good afternoon, ladies and gentlemen, and thank you very much, David and Jacek, for your introduction to protecting of computer implemented inventions and artificial intelligence by means of patents. Now let's turn to the soft IP. You know, I hate that term because even in soft IP and trademarks and copyrights, designs and trademarks, disputes and conflicts can be very hard. You have probably seen this cartoon in last weekend's The Standard. It's a cartoon made by Kamagurka. Well, I am a little older than most people here in the audience, but I do remember the day that my wife told me that, you know, one day we will see each other when we talk on the phone. Well, it sounded a bit like science fiction at that time, but now we're used to that. We're used to that with very smart tools like FaceTime, like WhatsApp, and like Teams. Well, with artificial intelligence, we're almost there as well. We are all familiar with the translation tool DeepL, which is the abbreviation of deep learning. But nowadays, artificial intelligence is much more advanced than you can even imagine. Well, most of you are active within the field of artificial intelligence and also in software. So maybe I am again feeling old, but what a kitchen robot will certainly not write books, but what about programs like GPT-3 of OpenAI, which is a company founded in 2009 by Elon Musk? Well, by way of introduction, let me give you an example, and I will use that example as a cloak hanger for the rest of my presentation. Okay, let's write an article about what would you suggest? Well, I have, because I don't trust technology, I have already made an example and made it in the presentation. What about writing an article of about 1,000 words on patenting software? Well, this is the output we get. The current version of GPT-3 was trained with about 2 billion sources of text. 2 billion sources of text on the internet. The next version that is soon to come out, soon to be released, has been built with about 200 billion sources of text. Now, this is what we get. A patent is a legal document that grants exclusive rights to an invention. Patents are awarded by the federal government and allow the patent holder to prevent others from making, using, or selling the invention without their permission, which is, as a definition, not really bad. Of course, this is the playground of GPT-3. It's a tool. It does not. It's not finished. But it is a good example of what artificial intelligence does. Now we can wonder about the content, what it really writes, but no.
Doe maar, dat gaat niet.
Well, we have, of course, the huge volume of data, the training data that is being used to have this system to learn, to work. Who owns the rights? What rights do exist on that data, and who owns these rights? What are the limitations to these rights? You also have the text. Who owns? Is this protected in somehow? And who owns the rights to the text? The algorithm, of course. The algorithm is the typical example of software. And then, of course, what can you do with it? So there are various aspects. You also have the domain name, you also have the trademark, you also have the interface, how the user interacts with the playground, with the tool. Those are all aspects of intellectual property that might generate an exclusive right you have to be aware of. Now, let's start with what is definitely not protected. David has explained in long terms that, as a matter of fact, software cannot be regarded as an invention susceptible of being protected by a European patent as such. So what they do is, of course, is to circumvent this exclusion by all kinds of methods, like it is a computer implemented method. So they circumvent the fact that they do not really patent the software as such. They protect the software as a means, as a method, as a system, as a storage media, in order to have it a technical feature, in order to be patentable. Patents do not protect the software as such. It is copyrights do, but there are limits. I will try to briefly review the particulars of copyrights and how these specific legal provisions may answer a lot of your questions. The basics. A work is protected by copyrights provided that it is the result of a creative activity. The creation of the human mind, expressed in a tangible form, which also includes computer programs. What cannot be protected by copyrights, however, is what is produced exclusively by a machine, such as, for example, artificial intelligence, exclusively by a machine. What is not created by a human being. They were thinking about monkeys making drawings, but not created by a human being also means that artificial intelligence, as such, the output of the GPT-3 text, as such, cannot be subject of copyright protection. And also technical inventions, this is David and Jessek's domain, are excluded from protection by means of copyright. So the text generated by GPT-3 cannot be protected by copyrights because it is not the creation of the human mind. However, any adaptation of the text we have seen, any revision of the text, any restructuring of the text, you might want to change the introduction and add other elements to the text, they can, irrespective of how important or small these adaptations, revisions, and restructuring may be. If the external constraints allow the author to some sufficient creative freedom, then the level of creativity actually required to enjoy copyright protection is fairly low. We have seen a lot of decisions are rendered by the European Court, for example, in InfoPack, that a short adaptation, even a short text, not more than 11 words, like in InfoPack, may be susceptible of protection, of enjoying protection under the copyright legislation. Also, on the basis of other decisions, like in Painter, where it was the creative choices made by a photographer using a camera and making a picture. He uses a camera to make his own copyright work. the copyright work may be, or a picture may be a copyright work because the photographer has made some creative choices. He used the camera as the instrument, like also artificial intelligence can be used as an instrument. You can, on the basis of artificial intelligence, also create a copyright work, even by making limited, very low textual adaptations or textuals. It may also be pictures to the work created by the copyright. Consider it as a pencil, as a tool, like a camera, and make your own creative choices. Adapt, revise, and restructure the text to some extent and enjoy its copyright. But what about the algorithm? Of course, the algorithm is a piece of text. It has been written. It is protected under copyright law. And the interface through which you work with the tool, with your camera or with the artificial intelligence, of course, this is subject of copyright protection. Even the interface and graphical representations on the interface may be susceptible of protection under design law. And design law does not necessarily have to be a registered design. There are also so-called non-registered designs. I'll come to that later. What are the conditions to enjoy copyright protection? Well, first, the work must be expressed in a tangible and a concrete form. It is not the idea or the concept at the basis of the work, but its expression in a concrete form that can be perceived by senses. This is susceptible of copyright protection. It is generally permitted to take over an idea, some would say to steal an idea, but to take over an idea at the basis of a work, to exploit it again, but differently, of course, give it a concrete form to it, but in a different way. This is perfectly possible. So it has to be a concrete work that can be perceived by senses, whatever. And finally, copyright protection may exist provided the expression is original. For the output of artificial intelligence to enjoy copyright protection, the following 3 steps generally have to be considered. You have the conception phase, the design and specification of your query, what you would like the artificial intelligence to achieve, the execution, the AI production of a draft version, and then finally, the redaction phase, selecting, editing, refining, finalization. The execution step, of course, cannot reflect the personality of one pushing the button. But the conception phase, where you have made your query, you have made certain choices, and also, surely, the redaction phase, at the end, the manipulation of the text, the output of the artificial intelligence, are susceptible of protection under copyright legislation. One of the main advantages of copyright, and the main differences with patents, of course, is that copyright does not depend on formalities. No specification and claims have to be drafted, as for patents. No official fees are due. Once the conditions of originality and concrete form are met, a work enjoys copyright protection. Full stop. That's all. It may be useful, though, to make sure you actually own the copyrights and to secure proof of the date on which the author created the work. Several possibilities exist to secure an undisputable date, such as various escrow services that are possible. You can date stamp software, you can date stamp artificial intelligence. You can also file digital files, such as a computer program, as in IDP, with the Benelux Office for Intellectual Property. And this is where we might come in. Then the basis, the legislation. General copyright, we make a distinction between general copyright legislation, also sui generis copyrights for software. It is a legislation that came into force in 2009. And the sui generis copyrights for databases, that was a bit later. Also, there is a new directive, but I'll come to that later. The general copyright legislation provides expressly for protection of graphical user interfaces. Aesthetic elements, of course, you're all familiar with that. The programming language and also specific program structure. Sui generis copyrights for computer programs further specifies that protection may be granted in respect of source code and also object code, preparatory design, the coding material, and also the expression of a computer program which allows the reproduction of the computer program. According to general copyright legislation, it is in principle the natural person or persons creating the work who own the right, but of course, subject to contract, the rights may also be assigned, transferred to the employer or the commissioning party. And this is where the second one comes in. According to sui generis copyrights legislation in software, the principle of author, in principle, the author of the work is still the owner of the rights, but there is an automatic transfer assignment to the employer in case of employees, of course, in the framework of their contract, of their task, if they, in the performance of their task, according to this second one, the proprietary rights to the copyrights automatically belong for software to the employer. Note, however, for freelancers, independent contractors, directors, and even shareholders of the company, they are not employees. And for the latter group of people, you still must have to ensure that contractual transfer of the rights. So even the shareholder, the founder of the company, he is not considered as an employer. He is not considered as an employee. And you have to secure for the, as an investment company, you have to make sure that also the founder of the company, who made the basis of the software, who owns, in fact, the copyrights or main parts of the copyrights to a computer program or to artificial intelligence, he's not an employee. You have to secure the transfer of the rights from him, from the founder, to the company, in order to make sure that the company enjoys the full rights. For sui generis copyrights, the databases, in principle, it is the producer, the employer who owns the sui generis rights on the databases. But the law also adapts to changing circumstances. With the growing interest of artificial intelligence, the law on copyrights has evolved as well. We have, since 2019, a new directive that, with a couple of weeks delay, has also been implemented in transposed to Belgium in the Belgian law of June 19th of this year, and coming into force in August this year. So this is very recent. There is no case law yet. There are still a lot of questions about this new directive and the new law, but the most important ones for people active within the field of software and artificial intelligence are those, namely copyrights exemptions for text and data mining, not only for research institutes, but also for commercial purposes. What we have seen before is you have to train artificial intelligence, you have to train machine learning equipment by means of massive volumes of data. The access to this massive volume of data is becoming much more important. And for the European Commission, the European Union, willing to invest more in artificial intelligence than before, they had to break open to make available information that is readily accessible on the internet for the sake of data mining. So research institutes may use that, but also commercial companies may use that. There are differences, there are also restrictions, of course. And of course, you cannot hack into databases in order to get access to the information. The information must be readily available. There is also the tax link for direct control and reuse of works of copyrights, which is believed that will significantly impact news aggregators. This has to do with the fact that those developing copyright work, like journalism, journalists, they also deserve a fair compensation of their effort. News aggregators will have to pay for that. Third, service providers hosting user-generated content to employ also effective and proportionate measures to prevent users from violating copyrights. This has to do with social media. You cannot simply appropriate copyright work or other protected works and use it online. Last but not least, measures to ensure authors and performers to receive an appropriate remuneration. Imagine, for example, that you have developed something, you have written a book, or it may also be from an e-reader, and it suddenly becomes a Nobel Prize winner, and the author has already been remunerated by the producer, by the editor, by the company issuing the book. In general terms, well, as because of the tremendous success, he will also may have the right to renegotiate the conditions for the transfer of his copyrights. So copyrights, I'm sure there's still plenty of questions regarding different aspects of intellectual property and artificial intelligence. And you can imagine what will happen within the next area of the metaverse. What is going to happen? Who will be the right forum for to pursue someone on the metaverse, infringing your copyrights, your trademarks, or maybe even your patents, provided you can explain, but you explain everything technical does. So how will we cope with that? We don't know. So we have copyrights, but we also have other types of soft IP. We have trademarks, and we have designs. Both terms you probably know. This is Apple and Nike. The latter one will, I believe, within a couple of years, also have the same level of knowledge or the level of reputation than Nike and Apple, which is open IP. I hate that trademark. It's a monster of a trademark. How can you ever try and defend someone claiming exclusive rights to the distinctive sign of open IP, open AI? Open is descriptive, meaning that it is free. It is available for others. And AI is a common abbreviation of artificial intelligence. So it's a monster of a trademark, but even monsters can become reputed trademarks sooner or later. And I'm practically sure that the shareholders of this company will manage them, as you see how they manage Twitter. Trademarks, very briefly, we have to close. So we have to have a distinctive sign. A sign that is merely descriptive does not feature, cannot enjoy exclusive rights in the form of trademark. And the logos, this is a combined sign. This combined sign may enjoy trademark protection if it is appropriately filed and also prosecuted through registration because of the figurative elements that give it. And though the sign with sufficient level of distinctiveness for it to be allowed for registration. Of course, its scope of protection is very limited. Design rights, the appearance can be two-dimensional, can be three-dimensional. We all know each form, a design is of course susceptible of protection under design rights, but we also have two-dimensional designs, two-dimensional, which may, for example, be the interface, the playground of a GPT. Provided they are novel and have individual character. Individual character, I have a very I have an example that explains what is meant by individual character. You all know the Mona Lisa, the famous painting of Da Vinci in the Louvre in Paris. Well, it is not sufficient to draw a moustache, ears, and spectacles on the Mona Lisa. You will still recognize behind that painting. You will recognize the Mona Lisa. As soon as you recognize the Mona Lisa, then of course you do not have a novel and a novel design having an individual character. And these rights may be cumulative with copyright and patents. A domain name is not an exclusive right. A domain name is just you register it if it is available, and that's all. It does not enter you with exclusive rights. It may be the evidence of a trade name, or may also be evidence that someone may have a trademark on that name, but make sure that your domain names do not correspond to earlier trademark rights. They may want you to stop or even to transfer the domain name. Exclusive rights to designs and trademarks are granted by registration. This is not always true. You also have the non-registered designs with limited term of protection for 3 years. One community design and one European trademark covers 27 countries of the European Union. We have the United Kingdom that has left the European Union. They are no longer part of the community trademark. So if you file a community trademark or a European trademark right now, do not forget a separate application for the United Kingdom, for they're not in anymore. A design is valid for 5 years, renewable 4 times up to 25 years. And afterwards, because there is also accumulation possible with copyrights, afterwards you may also own copyrights on your design. And trademarks are valid for 10 years, renewable each time, indefinitely for new periods of years. The ownership, contrary to copyrights, the ownership is principle of first filing. The applicant is presumed to be the owner. For designs, it is also the employer. And only in the Benelux, the commissioning party may also be the owner for the design rights. Then you have to be very careful. You have design rights and copyrights. Copyrights belong to the author. And the design rights, even for an employee or for a commissioning party, they belong to the commissioning party. There may be a conflict. So even if you have a good agreement between the author of the work and the commissioning party or the employer, then make sure that also the copyrights belong to the same party. So that's it. That's for the soft IP.